Hello everyone, welcome to my presentation. My name is Muhammad Nahidok Shajon and the topic of my presentation is envelope detection, the simplest demodulation technique. The subsequent materials are mainly taken from Modern Analog and Digital Communication System by B.P. Lathy, Chapter 4. At first, I will talk about the objective of envelope detection. The main objective of envelope detection is to detect the modulating signal in a simple and low cost fashion. So in this process, the amplitude modulated wave will be passed through the envelope detector and finally we will get the modulating wave. So here the amplitude modulated wave is our input and the finally modulating wave is our output. Now I will explain the block diagram of envelope detection. In this block diagram there are two blocks of the envelope detector. The first one is the rectifier block and the second one is the tunable low pass filter. At first, the amplitude modulated wave is passed through the rectifier block. So, the rectifier block blocks the negative part of amplitude modulated wave and we get this wave shape as the output of the rectifier block. Then, this wave shape is passed through the tunable low pass filter and the tunable low pass filter only allows the low frequency modulating signal to pass through that. So, finally, we get this wave shape as our output, which is the modulating signal. Now, the circuit diagram of envelope detector. This is the circuit of envelope detector, and this circuit we can easily detect the two parts. The first one is our detector diode part and the second one is the RC low pass filter. The input for this circuit is S of t, which is the amplitude modulated wave, and this is the wave shape of the amplitude modulated wave. This circuit performs envelope detection by simultaneous charging and discharging of the capacitor C. This capacitor charges through this loop and this capacitor discharges through this loop. So when charging, the time constant of the capacitor C is Rs into C, and when discharging, the time constant is R into C. So we want that the capacitor must be charged very quickly and the capacitor must discharge very slowly. So when charging we want that Rs into C must be much less than 1 by Fc, and here Fc is the frequency of our carrier signal. And when discharging we want that the capacitor must discharge very slowly. So we want that the time constant Rc is much greater than 1 by Fc. Finally, I will explain the waveform of envelope detection. From this wave shape, we can easily see that the capacitor charges when the magnitude of the amplitude modulated wave is increasing, and when the magnitude of amplitude modulated wave is decreasing, then the capacitor discharges. So finally, we get this green waveform as our output, and this red waveform is our approximated output. We can easily say that this red waveform is our modulating signal. So finally we get our output, the modulating signal, by envelope detection. That was all from me. Thank you for your patience.